Assalamu alaikum. Welcome to lecture 3 of chapter 8. Chapter 8 is, of course, phase diagrams. As usual, we will initially quickly review what we did in lecture 2 previously, and today we will continue with the discussion of binary isomorphous alloy systems, which we started last time. We will do some examples, more than one, on binary isomorphous alloys, and we will conclude binary isomorphous alloys by discussing non-equilibrium solidification. Then we will start a totally new system of alloys, binary eutectic alloy system. After describing that in detail, we will talk a little about slow cooling, and then we will do a detailed example on binary eutectic alloys. Let us see what we covered in lecture 2 last time. We introduced the binary isomorphous alloy system, mixture of two systems, two component systems, and so on. We gave you the example of the copper nickel system, telling you about the liquidus line, the solidus line, the tie line. This was the figure that we did, and we spent a lot of time on. We started talking about phase diagrams. How do we extract phase diagrams from cooling curves? We talked of cooling curves and change of slope and the thermal arrest. We showed you these two diagrams, the one on the left at different compositions, how the cooling is happening, the diagram on the right, how do we combine the L1 and S1 from each one of them to get the phase diagram. We started introducing the lever rule to find out the mass fraction or the weight fraction at any given composition and any given temperature. We further explained the tie line and how to do the calculations. We took another example, at different temps. We then continued with more examples and showed you at different temperatures what phases will be there, how do we do it. We continued further, more examples, different composition, different temperature, and what phases will be there, and so forth. So we continued doing this, giving you lots of examples so that you become really strong. Another example, more details, right? And we calculated, we applied the lever rule, and so. So this was where we were last time, and today then we start today's lecture, and we will start it with an example, and we will do this example in detail.
So now we will do a full example for you. Those examples were also there, but a full example. We have a copper nickel alloy which contains 47 weight% copper and 53 weight% nickel, and the given temperature is 1300 Celsius, right? Number A, what is the weight% of copper in the liquid and solid phases? Weight% of copper in liquid and solid phases. Second, what is the weight% of this alloy? What weight% of this alloy is liquid and what weight% is solid? So the first question is saying, what are the compositions of the liquid and solid? What are the compositions of the liquid and solid? And the second is asking you for the mass fraction or the weight fraction. Now, if this is a copper nickel system, then what would be given? The phase diagram of copper nickel will be given, and we know that the original composition of nickel is 53 and the temperature is 1300 Celsius. So you see this diagram, copper nickel diagram, must be given, which is given, right? But this time, you see, this is weight% nickel, and the percentage of nickel is 35 weight%. So this was the example, but now we find 35 as exactly as we can, and we draw a vertical line, and the temperature is still 1300 Celsius, so that is okay, right? So that is okay. So this is what we will be doing. If I have repeated the question for you here. Oh, sorry, my mistake. Not 35%, 53 weight% nickel. 53 weight percent nickel. I'm very sorry for that. So if it is 53 weight percent nickel, we have already done that in the example, right? 53 weight percent nickel, we have already done that. We draw a vertical line to as high as we can. And if the temperature is 1300, we do the temperature is 1300. From the temperature now, right? Now this point is here. So what is the answer to your first question? How many phases are there and what are the phases? So you will say there are two phases, liquid and solid alpha, right? There are two phases, liquid and solid alpha, because we are here. The second part, what is the composition of the liquid phase? We go here and we drop a line here and we read that it is 45 weight percent nickel. So the answer is that at the given composition, at the given temperature, the composition of the liquid phase is 45 weight percent nickel, 55 weight percent copper. What is the composition of the solid phase? Drop the line here, read it. It comes out to be 58 weight percent nickel. So the composition of the liquid phase is 58 weight percent nickel, which automatically means 42 weight percent copper, right? So this is the answer. You have answered the first part, that there are two phases, solid and liquid alpha. You have answered the second part, that the composition of the liquid phase is 45 weight percent nickel. The composition of the solid phase is 58 weight percent nickel. Now the last part of the question, what weight percent, what mass fraction is liquid and what is solid? So again, you remember, now this is the tie line, this is the lever rule. So if you want to find the weight fraction of liquid, you go to this other side, right? This minus this upon total, this minus this. When you go for weight percent or mass fraction of solid, you go to the opposite side, this side of the line. So this minus this upon the total, which is this minus this. So this is what we are going to show, right? This is exactly the thing that you found out, that the original is 53%, liquid is 45 weight percent nickel, solid is 58 weight percent nickel. So weight fraction of liquid phase is 58 minus 53, right? 58 minus 53 upon 58 minus 45, and so on. And you do both of them, and right, they are rounding out to two places of decimal. I would want you to round off to at least 3 places of decimal, so that you don't write 38%, you write 38.3% or 38.4%, whatever you are, so you are more accurate. So as we have done from the beginning of the course, I would want you to round off correctly, right? So that whatever is the 4th decimal place, you round it off to the 3rd one, and then that is your answer. So if it is 0.383, then that is the fraction, and in percentage that will be 38.3% nickel, and so on, right? So this is your answer, and this is the solution of the problem. Just to give you more practice, we are giving you a different system, alloy system now, silver, palladium. So on the next page, we will give you the phase diagram for this, and the temperature is 1200 and silver percentage is 70, and then we will solve it. So but this I leave it as a quick self-study, but right, the diagram is here. It is the silver palladium diagram. Temperature and weight percent composition are given, and now I am repeating the whole thing. The question is given, the diagram is given, and using the lever rule, you find the weight percent of the liquid and weight percent of the solid. And again, what they do, please don't do this. Please don't round off to 60%. Whatever fraction you get, try to get 60 point some percent. If you have exact numbers, then okay. But otherwise, just do whatever is said. So this is what we are doing, right? So whenever there will be a phase diagram given, there will be an initial composition given and an initial temperature given, and there will be always 3 questions. The first, at this composition and at this temperature, how many phases are there? What are the phases? Second question, if there are say 2 phases, liquid and solid, liquid and alpha, then what is the composition of the liquid phase and composition of the solid phase? And third part, what will be the mass fraction of the liquid and the mass fraction of the solid at this temperature and this composition? Okay.